All right, in this video, we are going to show you a quick reminder of how to prove something is odd or even. This is not meant to be the first time you have learned odd or even. This is meant to be a review. So, if you prove that f of negative x is equal to f of x, you have proven that the function is even. If you want to prove that it's odd, you'd use a different little statement. F of negative x would have to equal negative f of x. I try to remember that by saying, oh, they both have negatives. That's odd. All right, so the red one is the proof for it being odd. The blue one is the proof for it being even. Now, you can't be both, and you can have functions that are neither odd nor even. So let's try this one and figure it out. Now, the fact that it has a squared in it means it's possible that it's even, and it's more likely that it's even than it's odd. So I'm going to check this even one here first. So all I have to do is put in f of negative x, as in stick a negative x into this function. Now, I like to do it in a two-column proof like this format. And I stick in negative x into the function, and I put it right here, 5, and instead of x, I put negative x squared plus 4. And then f of x is over here, and so I'm going to put f of x, 5x squared plus 4, right there. And if these come out exactly equal, then I've proven that they are even. So that does come out to positive x squared, and I times it by 5 is 5x squared plus 4. And look at that. I just bring this straight down, 5x squared plus 4. It's true that when I put in negative x, it comes out the exact same as when I take the original function f of x. So that is equal to that, and therefore it is even. Obviously no point in checking to see if it was odd, because this one isn't. I'm going to show you a different one that is odd. Let's say that I had x to the third. That is the classic odd function. So how could I prove it? Again, I make a two-column proof. I put in f of negative x. So I take my function, which was x to the third. I'm replacing the x with negative x. And then I simplify that down. That comes out to negative x to the third. Then, on the other side, I put the original function f of x, which is x to the third, and then I drop a negative in front of it with a parentheses. And then I see, when I simplify that down, that it's negative x to the third is equal to negative x to the third. These are equal, therefore proving that y equals x to the third is an odd function. All right, there's proof of even or odd.